I'm going to show this. Billy Steels with a boat beside it. Tide's out a little ways. But I do got my camera down low, fairly low. And I will try to get it down lower if the tide continues to go out. Now I'm out in that area there where the light shines. As you can see here.
I watched the other car walk up. I one car and then was still way out in seconds.
Focusing here.
Oh, he got yanked probably.
Tide's out a little ways. But I do got my camera down low, fairly low. And I will try to get it down lower if the tide continues to go out. Now I'm out in that area there where the light shines. As you can see here. Focusing here.
Oh, he got yanked.
I'm no higher than 5 feet off the water. I know Billy Steele's rack is 9 miles out. Now, as your ball babies might say, that this is being refracted up from behind the curvature of Earth. And I asked them, you know, how in the world can this magical force be possible when you can't even go out and give us an observation of something that is not there, that magically appears, and, you know, honestly prove that this is being pulled up from the other side of the curve. Because at the height that I'm even at up here, up on the seawall with my tripod at a low setting, and I'm no more than maybe 5.5, 6 feet off the water. And, you know, I have to ask myself, you know, if a man 6 foot tall can only see 3.14 miles out, this bird rack is approximately 9 miles, and that's being conservative. See the marker there to the left with the bird on the top of it? That is actually about 2 miles from my location. Let's say 2.5. So between that marker and the bird rack, there's over, you know, 6.5 miles there, and that little sliver of water. And this is what, you know, people don't look at or perceive. I shouldn't use the word perceive, but perspective is something that when you're looking at a long distance, like looking at a board, the lower you get to that board surface with your eye level to the board, the less of the board you actually see, because it gets compressed into a tiny little sliver. Now, I've done did a little video on that, and also look at that boat as it goes by. You can see how the water glares off the sides of it, and it kind of cuts it off, but then you see its wake go by too. But if you're looking at that little sliver on top of a board, you know it's the whole length of the board. The board is, say, 7 foot. So you're looking at it, at eye level and all you're seeing is this little tiny sliver of board, how do you know what's at the end of it? Or if you had something very small at the end of it, would you really see it? Or would you think that maybe it's not there, and if you had a lot of light shining on it too, maybe you wouldn't even see it at all? So is it being projected up over it, hidden within the light? And I say it's hidden within the light because, of course, water is a very reflective surface. So you have this surface light refraction. Also, you have other optical situations, air density that creates miraging, mirroring. So this also contributes to lack of visibility. Now, once I get a good day of visibility and I see this rack completely out of the water, I can see it, a boat that's well beyond this rack. Now, that boat is not next or right behind that rack. That boat is well beyond the rack. So that boat is, you know, a lot farther. I'm not going to try to determine exactly how far away that boat is, but it's definitely behind the rack. So I shouldn't even see that boat at all. It should be totally hidden. And yes, you do see some distortion because my camera's wiggling and moving. Plus, you do see the distortion from the, I should say, the water density is causing this. Plus, too, there is a something well known. It's called downward refraction that none of the ball babies include in their, you know, observations, or I don't even think they observe. But I wanted to go lower with my camera, and I had brought my other tripod with me, and I wasn't sure on the height, but I did take some pictures that I'll include at the end of the video to show the height of the camera. Well, actually, it's a video to show it because I wanted to be more precise and, you know, let people see that I'm not bullshitting you about the height of my camera. And I never try to bullshit anybody. And if I'm wrong about something, I'd be more than willing to admit it. But I know the distances these because I've fished this area for over 25 years.
Okay, there's where my tripod was at. I was filming a little earlier. And I brought my other tripod down here. Put it right in the water. And if I let me put my camera right next to this camera and show you, that was up much higher. And there's the bird rack still in there. See? And there is a boat to the right. I lowered my perspective and still was able to see it. And I'm out there in the hot spot, just as I just showed a second ago, and you can't see shit out there. And even if I zoom this camera in 8 times, you still can't see nothing. That's 8 times zoom on a cell phone camera. Of course, I don't have very good focus on it when you're zoomed out that far, but you can't see shit out there. Focus, and then it ain't focus. As best as I can. I moved lower to the water, perspective has a lot to do with it. Because of course I made my angle sharper by getting lower to the water. Like I was just telling these people here, there's no way I can see this with my eyes because it is in the light. Let me show you what I mean by in the light. I know this is going to mess my focus up. I'll have to refocus, but it is in the light of the sun. It's in the hot spot, I should say.
Alright, I added the cell phone footage in there just so you could see that I'm not bullshitting about, my height. Now, I turned my ISO down a little bit, and you can still see the boat. You don't see as much of the light diffraction going on, but you definitely see it still reflecting up and causing this this blockage, of course. And I think part of that light diffraction has a lot to do with causing the mirroring, because a lot of times when you see stuff cut off, it's cut off in that mirroring area. And it could be that the water gets diffracted down, or half of it gets diffracted down, half of it gets diffracted up, and causes a mirroring edge in between, which also causes some downward refraction also. Or actually it just hides the boat. There's a lot of things that I could say, but I think the observations are proof enough if somebody just takes the time out to look at them and observe what you're seeing. Now I'm using the P1000, which has 125 times zoom on it, and it isn't a magical camera. It doesn't pull stuff up from over the curve. It can only see stuff that's within its line of sight. So this is within my line of sight, and sometimes, like I say, if the conditions are really bad, which today the conditions were very good, visibility was excellent, as far as I'm concerned. I think it can get better, because I've seen it better. Especially toward the end of the day, it can get better. And I was out here doing these observations for a few hours. So I've got quite a bit of footage, and there's one part where I catch this boat with a blue windshield, and it's a shrimp boat, crab boat. I believe it's a shrimp boat though, because I've seen it many times where I launch my boat from. So I'll try to make a quick video of it, because I've got it coming out here at about 3.5 miles away, or actually 6 miles away, because they come out of Hernando Beach. So I'm saying approximately 6 miles. It could be 5, because these channels kind of run strange. You'll go out in one direction and turn a little bit, and then turn another way. So they're not all straight, canals going out. They dredged out Hernando Beach. They dredge out most of these just so they can get their big boats in and out. And as you watch this boat at 3.5 feet, just a tad bit over 3.5 feet, like a half an inch. So my camera's at 3.5 feet, and at a half an inch, because it's actually a half an inch in the middle of the lens. So I don't try to, I was very skeptical getting into this, but I'll tell you, the more observations I do, the more I see how the light reacts, how the atmosphere reacts, or atmosphere, I should say, it has a lot to do with our optics. And under the right conditions, you will be able to see a long ways. But there is a point where the eyes, or even this camera with 125 times zoom, is not going to be able to resolve the edge. Now somebody might say, well, where's the background? Where's the background? Remember that table or that board I was telling you to look at? Now think about looking at a board that's 8 miles long, 10 miles long, and you're getting on a real sharp angle to it. Are you going to be able to see that whole board? No, not at all, because there's going to be a point to where your eyes just ain't going to be able to resolve anything, even if you stick something at the end of that board. So again, you know, the only way you're going to see this is with a zoom camera, telescope, or something of that nature. Now I'm going to put up a couple of pictures and the video of the height of my camera. All right, and I'll tell you, it's a lot different when you go out and do these observations. I, you know, took a rock to stick it down at the bottom to hold my tape measure straight there, straight up and down. So I'm not trying to cheat in any way. I try to be as honest with this measurement as I possibly can. And you can see I'm holding it down, and I'll go straight up and show you that it's at 43 inches, a little under 43 inches. So, you know, about 42.5 inches is my height of the camera to the middle of the lens. Should be about 42.5. I'd even take 43. I mean, as far as I'm concerned. But I got a couple pictures I'd like to show too. So, you know, let me get on to show those. Alright, as these two pictures show up, I tried to get them even, but I just couldn't do it. It wouldn't move up and down. But you can obviously see where this light diffracts up on the picture on the left compared to the picture on the right. The right side, that light is being diffracted up, blocking you out, where a lot of times this is the exact same spot that I get blocked out on a day where I don't have as good a visibility. But sometimes it's even worse when that mirroring occurs. I might not see this object at all due to the fact of the light diffraction, the miraging, the mirroring effects. These are all optical effects that affects our eyesight. And, you know, people want to say that it's light diffracting it up. And again, I say that there's a downward refraction too that refracts things down and not refracts it up. I've never seen anybody, Glover, actually show something being pulled up that would be, you know, say they do a little experiment and they hide something behind a curved ball, and, you know, show me with any kind of light beaming at it or anything that it's going to literally lift it up. And I don't mean using a trick of butane. I've seen somebody use butane to cause it to rise up. And there's no butane over the waters. So let's get off the butane. You know, you don't need to be snorting that stuff because it can harm your brain. Use your mind. Use your observational skills. Don't try to use tricks to fool people. Go out and use real live footage and do it right. And maybe somebody will, you know, see what you're doing and agree with you. But as far as I'm concerned, I disagree with that video. Thanks a lot for watching, people. I think I said enough, and I think my observations do speak for themselves. Thanks for watching.